Hello, my name is Claire and this is my demonstration for COMP3095, Assignment 1, Student Wellness Hub. I'm in Group 20 and I'm the only member. Here you can see my name, student ID, section, and photo. This project includes 3 microservices: the Wellness Resource Service, Goal Tracking Service, and Event Service. This project is built using Spring Boot with Postgres SQL, MongoDB, and Redis. Now I'll build the Docker Compose environment. I've cleared all the containers for a fresh start. The build process usually takes a while, so I've sped this part up about 8 times faster. Once it's done, I'll check the running containers. You can see that everything in Docker Desktop with the green indicators also appears here in the terminal. Green dots and matching ports confirms all services are up and running. Here's my Docker Compose file, which defines each container, the ports, and how they are connected. From looking at these matching ports, we can see that everything in this project runs completely inside Docker, no local IntelliJ services at all. The service manages mental health resource using Progress SQL and Redis caching. We got 200 OK response for all list and filtered lists get request. The post returned 201 created for new data. We're fetching the data to check and notice the response time. The second time is much faster because of Redis caching. The first call hits the database. Second is from Redis. Cacheable annotation handles caching. We'll check the database in the container. We can confirm that caching and database work together. Goal tracking service uses MongoDB to manage personal goals. And we can list all goals. And we can also filter by status. We can also create a new goal using post request. And we can also update a goal with put request. We can see that the data has been updated successfully. And we'll copy one specific ID to mark the status to complete. There you go. The status has been updated. And delete also worked fine. The goals are stored in MongoDB. Each goal has a category. The service uses that to call the Wellness Resource Service over HTTP using VIN. For example, calling get/resources category is mindful returns related resources from another container, which demonstrates inter-service communication. The event service manages community wellness events using Postgres SQL. We'll test out endpoint. All wellness events are successfully fetched. And we can also filter by date. And we'll create a new event using post request. With specific ID, we can update an event. And we can also delete an event with specific ID. And just like we mark the goal as completed, we can also use /register endpoint to register student. This is what our database looks like, and you can see category column. The event service also links resources from the wellness service using /resources category equals and whatever the category is. That's another example of REST-based communication between our microservices. Now we'll look at our integration testing with test containers. These tests start real temporary databases in Docker. You can see the green dots, and test containers spun up disposable Postgres and MongoDB instances. These tests hit real Spring Beans and databases, proving that persistence and logic work as they do in production. You can see that container has started and MongoDB 7 and event integration test file passed successfully. Now we're looking at Docker Compose file. All services run together via Docker Compose. Here you can see them with Docker PS. Wellness 9081 and Wellness 9081. Event 9082, goal tracking 9083. And we can also access our service endpoint. We'll try all three. And we can access service endpoints. We'll try all three. And lastly, we'll demonstrate stopping and restarting the environment. You can see all the green dots are back. Here's our project structure in IntelliJ. Each service has its own package and database. Cache, config, controller, domain, DTO, mapper, repository, and service. When a request asks for a category, the controller calls the service to get matching resources. The service finds them in the database or cache and returns the list. This is our one-page status checklist showing all requirements met: CRUD, caching, inter-service communication, integration testing, and full containerization. We confirmed our GitLab repo and Professor Access. We used AI for grammar summarization debugging for support. The most challenging part was fixing Redis cache errors and container communication issues. This was Group 20's assignment 1. Thank you.